talks, and especially a warm welcome to Sander Mertens, our presenter of today. Sander is Lector, Energy and Transition and Director of the Center of Expertise Mission Zero at the Hague University of Applied Sciences, the Haagse Hogeschool. A major challenge with renewable energy is matching supply and demand. Sander investigates how we can mitigate the risks associated with this imbalance in the early stages of system design in a way that leads to future-proof value creation. Sander, please take the floor.
Thanks, Ruud. Thanks for the invitation. And yeah, it's a pleasure to be here. So I want to discuss energy-proof industries. Yeah, as you explained, I'm the director of Mission Zero, our center of expertise. Let me see my sheets. You already have the next one now? No.
No, still the first one.
So at the moment, yeah. I'm the director of the Center of Expertise Mission Zero, and so a short bio of me. Mission Zero is focused on the circular and the energy transition. So have a look at this picture. It's the globe of us, and you see a human being there on top of it, and it's indifferently or sometimes unconsciously emitting materials and gases like CO2. But in fact, that's untenable with our crowded Earth nowadays. This behavior comes back to us as a tsunami of consequences, and that's what's happening at the moment with the climate issues and also with the issues with materials. So our Center of Expertise is focused on that, and we have 4 main research groups with whom we try to tackle these transition issues on the circular transitions and the energy transition. We always try to focus on the 4 main issues that we see in transitions. These are technical issues, economical issues, social issues, and governance issues. So cooperation in our Center of Expertise is within the DNA of our Center of Expertise. It's the key for our approach. And I'm the professor of one of these research groups of Mission Zero, the research group Energy in Transition. So my focus is the energy transition and the more technical issues. And I will discuss some of the issues that I see in my research projects. Try to get the next slide. Yeah. So sustainable operation. What is it? Nowadays you hear we discuss again about nuclear power, for instance, and of course the solar and wind power. Yeah, indeed, we need to prepare for the future, but how? That's the question. How will the future look like for companies? What future do we foresee? So you want your company to be prepared for the future, isn't it? For the next decades. So yeah, how does the future look like? We are not psychic, aren't we? So what does the future look like? Well, for sure, the future will be with lots and sun and wind turbines. Sun and wind turbines are the biggest energy suppliers for the future. They're also very cost effective. So the future will be with lots of sun and solar and wind energy introduced into the energy grid. And in fact, this has big consequences. what we already see is that we in fact have a kind of a war of the commodities. We in fact shifting from fossil energy, from coal, gas and oil delivered by molecules, towards energy from solar and wind plants delivered by electrons. So in fact, we electrify our whole energy supply and demand system. In fact, we move from molecules as energy carrier towards electrons as an energy carrier. So existing assets have to be replaced by new assets, and that brings about that old interests need to be changed. And because of that, there is in fact a war going on, a war of the commodities between the owners of molecule infrastructure and the owners of electrons infrastructure. So it's in fact a kind of a war. Everything changes towards an electrical system. The energy supply, the energy storage, the energy demand. So big change, and of course that ain't easy. It's in fact shift on shift on shift on shift, to the fourth power almost. A shift from centralized energy towards more decentralized energy by solar and wind plants. In the past, we had the central power plants, so centralized, but now it's more decentralized. We have prosumers, for instance. And it's also a shift from storage within the energy carrier, the fossil molecules, towards absence of storage in the solar and wind energy provided by electrons. So also a big change there, the absence of storage. And it's a shift from demand-centered, the storage is within the fossil molecules, and it's focused on demand of energy, towards more supply-centered energy system, focused on the supply of solar and wind energy. So that's also a big change. And last change, last but not least, a shift from, in fact, alternating current. We choose that alternating current because of the transport abilities of alternating current and the alternators in the central power plants. Alternating current in the past was better in transport of energy. But nowadays, that's not true anymore. We can change to direct current, and we do. It's more effective in transport. There are more suppliers and of the direct current, like PV or batteries, and also there's more demand of direct current, that LED lighting. We have fuel cells. It's all based on direct current. And at this moment, we are also able to deal with this direct current in an electronic way. We have the equipment for this now. So it's more efficient, and everything changes towards direct current. So big changes, big shifts from old ways of doing towards new ways. A big transition is going on. And this ain't simple because we shift towards the electrical system, and we shift towards a far more increased use of electrical power on the grid, and that causes congestion. These are some pictures of the issues with the capacity on the electrical grid. A picture of 2019 with only a small fraction of the Netherlands covered by red and yellow colors, where there are no or difficult to have transport capacities on the electrical grid. And nowadays, 2024, there is not much area left where we don't face the big issues with transport capacity. So almost the whole of the Netherlands, it's impossible nowadays to have a big transport capacity on electricity. And this picture is roughly the same for demand. So yeah, the transition isn't easy. That's the future that we have to deal with. This causes changes in prices, like we see here. And the left picture, euros per megawatt hour. During the peak hours of demand, we have the very high prices of the transport capacity, but mostly during midday, where the solar panels provide the energy, we have some negative prices. And at the right, you see the number of hours of these negative prices. They are increasing rapidly, exponentially. And yeah, how to deal with this? It ain't over yet, in fact. It's a very difficult problem to solve. The increase of energy consumption is faster than the increase in energy supply by renewable energy sources. Source is our world in data. We have a rapid increase in the use of electricity, for instance, with artificial intelligence, but also with the e-mobility and the e-heating. And yeah, strengthening the grid isn't that easy. We had a discussion with Elko de Vink from Stedin, the grid operator. And if we want to strengthen the grid and want to use a high voltage line, we need a 15 meter wide path through a city. So that is not available in a city. Or we strengthen the transformer station. Well, we need some 7,000 square meters for that. Also not available. So how to strengthen the grid, that is almost impossible. So we have to focus on more than only strengthening. Also, in the foreseen future, my advice is do not only rely on the law, because law is changing. If you look at the law in the Netherlands, for instance, on net metering, in the past we were to introduce a lot of solar panels on our homes, and net metering was allowed, but this won't be allowed in the future. So the laws are changing. Try to focus on what foreseen future do we have, and what problems do we cause with, for instance, solar panels. Also the laws from the European Union, the renewable energy target, for instance, for the countries in the European Union, that changes and it will change again. So in fact, concerning laws, it's at least uncertain what the goals are. Try to focus on the big trends that could be seen. And one of the big ones that we see is we have a lot of solar and wind energy. Solar and wind energy is cost effective. These are the big power suppliers, energy suppliers for the future. The left picture is what energy is delivered by solar energy during the year. And of course, we have a peak delivery at the summer months. So if we introduce lots of solar energy, we face difficulties with the introduction of lots of energy during the summer months, where we are on vacation and where we don't need that much energy. So if we focus on solar energy, we will focus problems with unbalance, issues with we have a lot of energy introduced into the grid that we don't need in the summer months. If you look at wind energy, it's a different issue. In fact, wind energy is matching our demand in a better way. Wind energy has a peak during the winter months where there are more where the density of the air is bigger and where we have higher wind speeds. So in fact, wind energy is a better fit on our energy demand during the winter months where it's dark and where it's cold and where we need more energy. So try to focus on wind energy if it's possible. And if it's not possible, you for sure will face issues with unbalance and congestion. About the energy carriers, we talked about the energy carrier electrons instead of the molecules in the past. But in fact, we have three basic energy carriers: the electrons, and I already mentioned that we go towards direct current. The molecules, in the past, the fossil energy, but in the future, this will become hydrogen. Hydrogen as a building block, I think, a building block that can be changed into almost everything. For instance, methanol, if it's easier to store methanol. And heat, where the focus of my research group is mostly the low temperature heat, because that has a higher efficiency with the heat pumps. So 3 energy carriers, and in fact we have to use them all, because the electricity, the electricity carrier is a bit difficult at the moment. We face congestion issues. And these 3 carriers, they enable a domain shift. So they allow us for extra capacity on the infrastructure. So we should use them all in a kind of energy hub. Energy hub, what is it? It's in fact the local link from energy demand towards energy supply and storage capacity in a so-called smart multi-commodity grid. So based on the 3 energy carriers that I showed. That's an energy hub, and that can be used to overcome the problems that we face with congestion. How to deal with this? Well, we should find consensus on the energy carriers that we use. In fact, an energy hub is an energy system with multiple energy carriers that has clear benefits in terms of quality. And quality is, it should introduce flexibility, robustness, an integral approach, etc. So, yeah, how to realize this? We always try to focus on a living lab approach for that. And we make use of this living lab. It's an experimental environment where we involve all stakeholders. It's the picture at the right. So we have an experiment in a very uncontrolled environment where all stakeholders share ideas. This is in contrast to the somewhat classical experiments that take place in a very controlled environment. In such in a living lab, we try to find consensus on 4 main issues in the transitions. And these issues are technical issues, economical issues, societal issues like participation, etc., and governance issues. Is it allowed, or what are the responsibilities of the stakeholders? So this consensus forming is very important, in contrast to classical experiments where you have a more controlled environment without any influences from outside. And with that living lab environment, we try to find the best energy hub. And a good energy hub keeps the energy local. That's simple and has a small social impact. In contrast to the big issues that we face with a more national strengthening the grid, that's far more complicated. adding a heat grid, for instance. So that has far more impact and is far more complex. So the solutions. The issue is to keep the supply and demand of energy local and avoid unnecessary transport of energy. And we could use the energy hub to achieve that and design a business case with the energy hub based on risk mitigation, avoiding stranded assets, value creation. Some examples of this in the Schiphol Trade Park, the first 4 companies, they occupied all grid capacity. So there was nothing left for the other companies in the trade park. And they decided to share energy, and they designed a virtual power plant with all the supply that was available for the various the companies. And they shared that. And at the moment, the trade park is now up and running with numerous companies. So they solved the issue of having no transport capacity left. All the transport capacity was occupied by the 4 first companies there. But they are now have a big trade park up and running. Another example, at our university, we have to renovate our headquarter building. At first, we opted for a Paris-proof building, in fact, the European law. But that could be reached with not so future-proof means. And later on, we decided it's better to be future-proof and include Paris-proof in this future-proof concept, and without only focus on being Paris-proof only. Another example, along the A15 road, there is a big wind farm that could not easily sell its electricity to the grid. And they installed a large demand by means of a charging station. And now the energy supplied by the wind turbines is kept local and sold at higher prices. Last but not least, we work together with a grower, Corporate Cress. We have a Grow Fund project from Groen Vermogen. And the project is called Hydrogen Use, High Use. And in this project, we cooperate with Corporate Cress at the Westland, a grower. And we as researcher had the idea to replace the fossil-based combined heat and power plants by a fuel cell. And Corporate Cress added the business case fueling at the grower. So this means producing hydrogen at negative electricity prices, where we face big transport issues, and selling it to the trucks that are offloading at the grower. So, in fact, there are all kinds of ways to deal with the big issues that we face. The issues caused by the energy transition, the change toward electrons as an energy carrier. So, we need to be future-proof, and you now know how. Include legislation in this, but do not rely on legislation as a solely guideline. Base your future-proof energy system on the trends and prepare for that. But be aware, it ain't easy. You should include the Living Lab approach for that. That's a difficult process where you should include the ideas and co-design together with all stakeholders. So that was my presentation. Thank you very much.
Yeah, thank you, Sander. Interesting presentation and a complicated subject with many different angles.
Yeah.
I'm
True.
convinced there will be a number of questions and that we can have an interesting discussion on this. René, can I give you the floor?
Yes, absolutely. So thank you, Sander. Very interesting presentation, and it's indeed quite a challenging, quite a challenge to basically make sure that supply and demand are aligned all the time in a renewable energy system, and that is a crucial issue that we have to deal with. And one of the things that I encountered when talking to industries is that they often say, well, we can do a lot more in terms of flexibility, in terms of energy use. For example, a company like Nearstar in the south of the country, a huge zinc smelter that also advertises themselves as being a kind of a battery. It's not really a battery, it's more like they can scale down operations on demand. And if the price would be right, then they could really be an important factor. It's a significant amount of energy that they use. You could also find it in other industries. The problem that I run into is that there is no such thing as a kind of a national systematic approach towards this demand steering, let's say, for these different companies. If that would be the case, I think a lot of these fluctuations in energy prices could be moderated by that. So I'm just wondering what your thoughts are on this more systematic approach to the total energy supply and demand of a country like the Netherlands.
I totally agree, René. There is a lot possible, but it's we have to find out partly. There are no laws ready. There is no overall approach towards this. We are in fact in a transition towards sustainable energy. So we face the difficulties with it, with the change. So that's a normal issue with transitions. In fact, that shows that proves that we are in this transition. So we should discuss the issues together and try to solve them in a kind of living lab approach. Try to find the best ways to deal with this. The only way to deal with it is to discuss it together, to have to find the cooperation in this and share ideas. It's the only way. So I hope that, for instance, municipalities and the government is listening. They get more and more involved in this kind of living lab approach, but for them it's also experimenting. They're not used to. In the past, they had ideas and the ideas were carried out, but nowadays the ideas should be shared with all the stakeholders more and more. So they're not only in the lead of the transitions, and they're not used to that.
Yeah. So I agree that the living lab approach is very useful, let's say, also in smaller contexts where you want to bring different groups together, let's say, to think about creatively about solutions. I think that's an excellent idea and works very well on the smaller scale. I'm just not sure if it could also can it also work on a national scale. I mean, of course, you could bring parties together, but I think what is really needed here for on the larger, let's say, national level is something like a director that actually says, okay, let's look at this from the total perspective. We have a couple of huge users, and we can be fluctuating with Tenet and as a huge intermediate there that could also play a role. So yeah, how do you see that?
It's all about the companies that want to join in this transition and share ideas. A lot of companies are also waiting for the transition to happen. It's difficult to have a top-down approach. It should also be bottom-up. So partly top-down with ideas and vision, and partly bottom-up. So in fact, I guess we are experimenting in this, how to move forward and how to scale up. We have lots of projects just on the issue how to scale up, how to accelerate, because it's going too slow. European also sees that it's going too slow. We faced the big issues with the climate transition yet. Increased temperatures, lots of disasters going on, extreme weather. It's going too slow. But how to accelerate?
But I do think it's indeed a mix of let's say top-down vision and approaches, let's
Yes.
say, and the bottom-up thing. Yeah.
Because in the past, I tried to show if we introduce lots of solar panels and solar energy, we will face the problem that we introduce the energy during the moments in the summer where we are on vacation, where we don't need that much energy. It's light, it's not that cold, so we don't need lots of demand for heating. So we introduce the energy where we don't need that much. So focus on wind energy in order to avoid these problems, and more or less focus on the mix of the energy of solar and wind power in order to have a more reliable mix, and try to tune this mix on the demand. And at forehand, try to avoid the storage of energy, of solar energy. So we know it at forehand, but try to focus on this.
Yes,
I
thank
might get back to some of these points later, but I would first like to give the word to Peter Krechting.
Yes, morning. Thank you, Sander, for the presentation. We're taking some zeg maar international, some countries around us have elevations and have hydro power, and are also in some cases able to pump water back, so use it as a buffer.
It's a storage.
Can this play a role? What are the laws of scale for these applications? Can it play a role in our buffer problem? What's the efficiency? What be the contribution and of hydropower installations in the problems that you mentioned?
Yeah, so of course it's important to have a kind of a European energy network. And storage plays a big role because solar power and wind power are intermittent. As in Netherlands, they also discuss to produce hydrogen at the North Sea, and producing hydrogen as a storage means. It also involves efficiently. If we produce it at the North Sea, we in fact throw away all the heat that is produced. Some 20% of the energy is heat if we produce hydrogen, and so it's also on system choices. For instance, I don't think we shouldn't produce that much hydrogen on the North Sea because we throw away that heat. We should produce it onshore instead of offshore, and use the heat produced in heat grids. So it's important to look at efficiencies and try to find the best efficiencies. If we do not, we have to install extra solar power and wind power. So try to at forehand avoid efficiency losses, and try to at forehand match demand and supply instead of directly focusing on storage or producing hydrogen. But it's needed, storage, and try to find the local best sources in order to keep the supply and demand local, and try to avoid to use the grid and directly transport the energy. At the moment, we largely use the grid as a kind of storage means, but that means that we focus on the central power plants at the moment as a kind of a storage means. That is expensive. If we have lots of solar and wind power available, these central power plants are only operated during peak hours, and that is very expensive. And of course, we should avoid the use of fossil energy.
And you
Okay,
see
then,
no role for
yeah.
hydropower or links with countries around us, because I once heard that the turnaround efficiency of such an installation can be over 70%, and that's hardly achievable with hydrogen.
Yes, indeed. So there is a lot of storage in hydropower, for instance, in
Okay.
Norway, and we should,
Yeah.
of course, use it, and we use it.
Yeah.
We have a cable with direct current going to Norway, and we use the storage capacity there in a kind of a European network. And in the future, we will also face that we use hydrogen from countries where there is a lot of solar energy available. The formal fossil energy providers, they change, they make a transition towards more solar energy. They have big investment companies, so they are very important for the change towards solar energy. They, in fact, help us to go down the learning curves and make solar power more cheap. So yeah, it's important that we share and try to work together in this, and we do, in fact.
And there you see the system with the combination of solar power where it's available, and then transport the hydrogen as a better option for the future.
I'm sure that this will be there in in some 10 years or so. I'm not sure about the time frame, but we should, of course, not only produce it ourselves to be independent, but it's probably coming from countries with lots of solar panel power available and in a very cheap and very cost-effective way. And they have more than double the solar panel compared to the Netherlands.
Okay, thank you.
Thanks. And then Martin, you also had a question.
Yeah. We're talking about solar and wind. In the discussion, nuclear is also being mentioned, but it will take some time before it's ready. And
one of the issues, exactly.
Dependency on where the nuclear units will come from. What's your opinion about whether or not we should use that as a source?
Yeah. So one of my biggest issues with nuclear power is that it's taking some 10, 15 years before we have nuclear power plants. And we in fact need the decrease in CO2 emission at this moment. And solar and wind energy are available at this moment. The other issue is perhaps that it's kind of a base load, the nuclear power plants. Although it's flexible in France, I'm not sure how they do that. But flexibility is important for our electricity providers. Yeah, I'm not fond of nuclear power as it's also producing waste. It's not sustainable in that way. But perhaps it's needed if we are not fast enough.
Yeah.
So
I've been in Bosselen, and it's pretty impressive to see how much energy from just a small footprint will come from the regular footprint, not CO2 footprint. But I've also been in Pripyat, and it's pretty dense to see what happened there. So yeah, I'm not pro, and I'm not really calm. So I'm still struggling with that. But
it's a bit the same with me, but I think it's a big issue that we need the CO2 reduction at this moment and not in 10 to 15 years. Yeah. And also nuclear power has shown to be very expensive. So I'm not, I don't think that the price level will be interesting. So probably the government needs to provide guarantees to the energy companies on the price levels or somehow. But it's shown to be to be expensive, and the learning curve of nuclear power is going upwards. So instead of learning, the price is going upwards, and the price increases because there is a local focus on issues, so they can't learn. In fact,
yeah, it's typical that this discussion is popping up again.
Yeah.
After Mr. Van Geel tried it, and later on all other parties, and now again, let's discuss it, and nothing happened. So but how can we get to a storage system which is less technically dependent? Because harvesting lithium is it's also giving lots of issues. What's the least technical dependent storage which we can get in Holland? Not just the hydrogen.
So we talk about storage, then for the short term, it's batteries. They get better and better nowadays. So very efficient for short-term storage. Also, a lot of storage will be available in the e-mobility. The cars, the batteries, we need to use them in a bi-directional way.
Yeah.
That will happen in the near future. But for the long term, seasonal storage, the storage in heat will be interesting. Storage in so-called WKO, the storage
in the ground.
In the ground. So that's a very cost-efficient way to store the heat. It's shown that it's also possible at higher temperatures too, from 50 degrees. So that is a very interesting option for seasonal storage.
Yeah.
Seasonal storage is not able, batteries are not able for seasonal storage.
Okay, thanks.
Yes, Sander, you started with normalized data on solar energy generation and wind energy generation. What would be the optimal ratio between solar power and wind power? Did you look into that?
Yeah, I wrote especially on that. I wrote a paper because I think we should focus, as I said. What is the best mix for the Netherlands or for the European Union in order to avoid the large use of storage and efficiency losses? If you look at the Netherlands, we should at least have some 5 times more wind power than solar power. So a big focus on wind power because that's available during the winter months and has a better fit with our energy demand.
And if you then look at currently installed capacity, how far are we with solar? How far are we with wind?
Yeah, we are moving forward with that. We will introduce more and more wind power, especially offshore. But again, there is discussion going on there because the government wants to earn money from selling square meters of offshore area for wind turbine parks, and the big companies that want to invest in an offshore wind, they draw back. They think that it's getting too expensive to install the big wind parks. So I think the government is a bit too early with trying to earn money with that. But more and more wind energy will be introduced. But at the moment, it's a bit difficult with the price level.
Do we also still need to introduce a lot of solar if you look at those that ratio that you anticipate, or becomes that less important because we already have a reasonable capacity installed?
Well, yes, we should install more and more solar and try to keep it local. For instance, with storage in heat. we should introduce much more solar power and wind power in order to have a good energy mix and of course sustainable energy. We're not there yet.
And the local brings me again back to the living labs, which indeed can be a very interesting concept. You briefly discussed 4 examples, and you are quite optimistic based on those examples. But my question here is, what are the main insights? Usually you do living labs because you also, well, you have the complexity of the environment and of all the stakeholders playing a role. You don't have the controlled experimentation, but you do it because you want, for instance, to learn something about behavior of various stakeholders and how that is affected by various conditions. So in that respect, what insights did you obtain and what changes might be needed to make these things more effective? And then I don't mean living labs, but the way in which we use energy locally.
Yeah. Well, yeah, you mentioned that I'm optimistic. Well, in fact, the use of living labs is the only way. We have to cooperate in this and try to find consensus with all the stakeholders. But it isn't easy. It's in fact very complex. And what we face in these projects is that there are, of course, the issues that I mentioned with technical issues, economical issues, social issues on participation and governance or law issues. For instance, could be not allowed. Introduction of hydrogen, for instance, couldn't be allowed somewhere. So we face various issues and try to solve them in these living labs. And what we mostly also face is different time schedules. The business case is mostly one of the biggest issues. So we try to be creative in finding good business cases. And for instance, with the renovation of our own building, the headquarters of the Hague University of Applied Sciences, we try to be creative in the business case and try to get the normal costs of operation and maintenance a bit earlier and prevent the future costs on that, and in that try to have more financial means to invest in a future-proof situation. So yeah, be creative in the business case, and that's mostly one of the biggest issues.
So
but again, it's difficult.
Would you say that currently economic drivers are more important than the technological and social drivers?
Yeah, I would almost say yes. Yeah.
Okay, thank you.
No.
Any other questions?
I don't have a question, but I have a remark that René has been putting some links on the chat about, for example, an alternative way of storing energy with hydraulic power, well, pumping a river empty, and also some links on nuclear power.
Yeah, indeed, clarifying, at least adding to some of the discussion we had.
Yeah.
If there are no further questions, Sander, I would like to thank you very much for your presentation, and people present for your contribution. And I hope to see you next time in 2 weeks at our next Circular Industry Talks.
Thank you very much.
Have a nice
day. Thank you
day.
for the invitation. It was a pleasure to be here.